If you guys could all fill out this attendance form, it's what gets us money so we can get pizza. So if you could scan it so we can get pizza for next semester, that would be greatly appreciated. The weirdest project I've ever worked on.
Weirdest project that you'd be proud to present on your portfolio.
I have no idea. I don't think I've ever done like a project that I would be like, oh, that's weird. Why do you have a weird project that you worked on?
How about, let's not use the word weird, let's use the word different.
Different?
The most different product.
I mean, I've never done machine learning before. My IPPD project is machine learning, so I'd say it's probably that. Hi, Mom. I see you on Zoom there. Eric, I know it's you. I bet anything I own, that's Eric.
Oh, yeah, that's that.
My mom said to me, hi, Michael. All right. All right, guys, we're going to go ahead and get started. Welcome, everyone, to SSD. We've got a pretty fun, informative meeting for you all today about the topic that is not exactly hot and popular anymore, but it's definitely still around and important. And that is, oh, sorry. Before we get started, we have a last half-a-thon. Is that accurate, or is there one more? Okay, so one of our last half-a-thons for the semester, Saturday, 12 to 3. If you don't know what that is, you just go to the library and hang out and do some work. Oh, am I not sharing my screen on Zoom? Whoops. There we go. All right. And then next meeting is going to be lightning talks and elections. And we'll talk more about that at the end of this presentation. So the topic of this week's meeting is cloud fundamentals. As I was saying, it's not super popular like AI is right now, but it's still definitely important, still definitely used all around. I've got some statistics for you guys that will show how important and relevant cloud fundamentals still is. So here's what we're going to talk about. I'm just going to introduce myself a little bit. We're going to go over what cloud computing is, the value proposition of it from a business standpoint. And then we're going to talk about AWS because I am certified in AWS. But these topics do generally apply to most other platforms like Azure and Google Cloud. And then we're going to talk about some tools to make using the cloud easier, and that's infrastructure as code. So let's get started. So I'm an AWS certified cloud practitioner. I have experience with ECS, EC2 instances, S3 buckets, using AWS Lambda, Route 53 for networking, provisioning IAM roles, and accessing Amazon Aurora database. So I have a pretty decent amount of knowledge in AWS. I'd say the one area where I don't know a whole lot is machine learning. So I won't be talking a whole lot about AI and machine learning in this topic or in this presentation, but that is something that is offered by AWS. So what is the cloud? The cloud is like a very mystical concept, but it's really very simple. The cloud is someone else's computer. That's all it is. It's just using someone else's computer to do whatever computing tasks you need to do. So a couple things have made the cloud much more popular and economical in, I would say, the past 10 to 15 years. And that's improved internet speeds because everything that you need to do related to the cloud has to go through the internet so that you can tell someone else's computer what to do. Economies of scale is just referring to the fact that having your own servers in your own data house with your own IT staff, with your own security gets very expensive very quick. And Jeff Bezos, that's just a joke, but AWS is the big cloud provider. And we're going to talk more about the services offered by the cloud, but in general, you can basically use it just like any other computer that you own. And then there are obviously specialized services that make things a little easier for developers. So what happened to all the hype? Like the cloud used to be the big thing. Well, honestly, the hype just turned into reality. The cloud is a $600 billion industry. AWS is estimated to serve 40% of all internet traffic, which is pretty huge, honestly. And there's value for both big and small companies to use the cloud. So for small customers without the cloud, you have to pay for basically everything involved with your technology. So that's the actual hardware of your servers, a data center, which is, you have to pay for the land, the building itself. You have to pay for IT staff to manage this data center. You have to manage cooling for all these computers, backups and replication. And, all of this is coming out of your engineering budget, which is taking away from your ability to actually, develop your product. So basically how this works is you're paying AWS to manage, or not just AWS, but whoever your cloud provider is, to manage all these things or most of these things and make it much easier for you. So this is basically how it is. We got this big server room and the whole world is in harmony because we share the server. And so now we're going to get into how is that safe? If everyone's got all their stuff on the same server, that seems a little dangerous. Is someone going to be able to access your stuff? The short answer to that is no. AWS and all the other cloud providers use super advanced VM technology that's called a hypervisor. And you can basically think of this as an operating system that looks over every other small operating system that is running on the hardware. So whatever your quote unquote computer is literally just a VM running on the server. And again, that allows you to use only what you need when you need it. And it prevents the VM from accessing another one's data. So even if your cloud VM is on the same physical server, even the same CPU as someone else's stuff, there are a lot of protections in place to make sure that there are no issues with, security breaches. And so just a little bit more about security before we go into the fun stuff. AWS has a model called the shared responsibility model. And this is basically a contract between the customer who uses AWS and AWS themselves. And the easiest way to remember this is that AWS handles the security of the cloud, which has to do with the physical location, the fire, the cooling hardware, break-ins, and operating system in certain instances, right? So AWS has managed services and unmanaged services. And we'll get into what that means in a little bit. But if you use an AWS managed service, then AWS also takes care of that issue as well. However, if your app is not secure, that doesn't, it doesn't matter if the cloud is secure because your app isn't secure. So you handle the security in the cloud. So this is referring to, like an HTTP response, a firewall on your server, good passwords. And then if you have a user managed service, then also patching your operating system. So this is like the actual security of the app, and that still remains your responsibility. And so for large customers, obviously, who can maybe afford to have a data center and have IT staff, there still are a couple of things that allow you to focus on development first and not have to worry so much on all the logistics that go into having a data center. So these are the 5 pillars of a well-architected framework. Operational excellence just refers to being able to iteratively provide value on your offering. I realize I'm blocking it here. And basically it's referring to basically always being able to focus on your actual product and not the implementation details of how you're hosting the product. And when I say product, I'm specifically referring to software here. Security, obviously, AWS has a lot of good security measures in place. They don't make up for bad development, like I said. Reliability, so AWS has regions and availability zones. And what this means is that whenever you configure your system to be running on AWS, you can replicate it across regions and across availability zones. And what this basically means is that in the rare event that a natural disaster or some other event happens to an AWS data center, you're able to automatically, let's say you have something running in multiple regions, you're able to just route the traffic away from whatever region has an outage. And so there will be no impact to your customers whatsoever, because they're basically just accessing somewhere else for that same data. And we'll talk about what services actually do that later on. Performance efficiency, this is a big one. So it can be really hard to estimate how much hardware you actually need. And so the great thing about AWS and other cloud services is that they give you insights through charts about how much compute usage you're actually using. And then you also have the ability to reserve compute resources in advance, which allows you to run stuff like batch jobs. Imagine running a batch job only at night when the cost of using that computer or the shared resources is low, versus having to do it during the day or having to pay for hardware that runs these batch jobs and then it just sits inactive the rest of the time, right? So the fact that basically the computers in the data center are running all the time because there's always someone who needs something done basically just makes it a lot more cost efficient than having your own data center and having those computers go unused at times. And this also goes into cost optimization. Okay, so let's talk about some of the AWS offerings now. So an EC2 is basically just your own virtual computer. You can use it like any other computer, like, you know, it's yours. The only difference is that you're connecting to it over the internet. So we're going to go through just a quick little demonstration of how you can set up your own EC2 instance later on in the lecture. But for now, basically, you just pick everything related to it. So you pick the operating system. You can have, you know, Linux. You can run Windows. You can also generate your own custom operating systems if you were really into that. And you can run whatever you want. I mean, it's really your own computer. You choose how much CPU utilization it gets. There are abilities to make it elastic, where basically it'll automatically scale up with however much traffic that computer is getting. You choose how much memory, you choose how much disk space it has. And you can literally just SSH into this like a regular computer, and you can give it a public IP address and just start, you know, a server on it and just start serving stuff to your, you know, whoever. So again, this is like EC2 is basically like you do all of the work related to actually serving it. They basically just give you a platform on which you can do whatever. ECS is containerized. Does everyone know what containers are? Just in case anyone doesn't know what containers are, basically, you are packaging your software into imagine, so VMs are running on these cloud servers, right? You could think of a container as like everything that, how do I explain this? You can think of a container as everything that VM needs in a universal language to be able to run whatever your program is, right? So an example of a container orchestrator is something like Docker, right? So you have a bunch of containers and you just tell Docker, no matter what type of computer on, Linux, Windows, whatever, I want to run this container, and Docker will be able to take care of that for you. And so basically what this means is that you don't have to worry about programming for a specific operating system or anything like that. You just give it the containers and it runs the containers. And you can make these elastic, so it'll automatically replicate more containers, which is like having more versions of your program running, and it'll dynamically route traffic to whatever you're trying to do. And then Lambda, which is really good for cost saving, is a serverless architecture. Basically, what this means is that you give them your code, and whenever your API is called, all it does is run your code and then give the output. So you don't have to pay for a computer to be on at all times. You don't have to pay for certain resources to be running at all times. You only pay for compute time. So however long this computer takes to run your code, you just pay for, imagine, it takes 1 second, but then you go 5 minutes between another request. You're only paying for that 1 second every 5 minutes versus having this server on at all times. So that's really good, especially for personal projects. If you're trying to get familiar with AWS and use it for an API in a personal project, I would definitely recommend using AWS Lambda, just because it's super quick, super easy. You don't have to worry about any server configuration, anything like that. It takes input. You can do whatever you want with your code and then just return an output. It's really that simple. And if you've taken, yeah, what's up?
Like how can you charge only for a second? Yeah, like when, between requests, it's only like it's like 5 volts.
So the way that it works is when you make, so AWS will give you a public IP, right? For your Lambda, whatever your Lambda function is. And that public IP is routing to AWS. So AWS's servers are listening for that public IP. But you're not paying for the servers to listen on your public IP, right? And when your public IP gets hit by, whatever request is coming from the internet, all they're going to do is start a timer, run your code, and stop that timer. So however long it takes your code to run is however much they're billing you for.
Okay. Are those like servers shared by other people who use
Yeah.
them?
Yeah.
Okay, interesting.
Yes.
Yeah, one note I want to share on that is, I'm not sure if all like Lambda providers, all serverless providers use the same way, but I know, some serverless, apps like Google Cloud Run will only like start your app whenever there's a request. So, in the 5 minutes, for example, where it's listening, but you don't actually have a request, your app won't be like running anything at all.
Yes. Lambda works the same way.
Yeah, okay, so it won't actually, Amazon like won't actually start your app until you get the request. And that's why it makes sense kind of from a money perspective, because they're not running their server 24/7. They just start it up when you get a request. Downside of that is that if your app takes a long time to start up, it can cause a performance. So there is a trade-off there.
Yeah, again, that's why I said best for small APIs. If you don't have a lot of overhead that has to be running. For example, like imagine you did a personal project where you're just trying to get familiar with APIs and you're making a Lambda function that returns the square root of a number. Obviously, you could do that on your computer, right? But the purpose of it is that you're trying to learn about how to use Lambda. You could make a Lambda function that all it does is returns the square root of a number, and then you get familiar with using the fetch JavaScript library or Axios or requests in Python. You're learning about how to actually interact with the API and not necessarily about what the API is giving. When it comes to like bigger stuff like companies, I can imagine serverless, like a Lambda function being good. Like imagine you need to retrieve a company's menu, a restaurant's menu. That would be a good example of something to be serverless because you hit this API and all it needs to do is just return a string, right? The menu is not changing at any time. So there's no overhead of, oh, we need to instantiate this class. We need to parse this data or anything like that. It's just saying, get the menu. You just return the menu, right? So there's minimal compute time involved with that. And so that's an example of where Lambda might be good. Because again, also you don't have to manage like operating systems or anything like that or server software. It does all of that for you. So it's called serverless, but there is still a server. Just like how, in the cloud, you don't think about using the computer, but there's still hardware that your stuff is running on. It's just that AWS is managing everything related to the server. You just give it the code to call when it gets hit, basically. Oh, okay. Yeah. So basically what he's saying is like, if you have a lot of overhead for whatever you're working on, you can have that so that overhead is always stored. And then you're paying for the compute time, of whatever processing you need to do. And it doesn't have to reload that overhead every time. So another category of AWS offerings is storage. So there's a lot of acronyms when it comes to learning the AWS ecosystem. You'll get used to them as you go. And if you want to be a certified cloud practitioner, you just sort of have to memorize them. It just kind of is the name of the game. So a couple of the storage offerings of AWS. The first one is EFS, which is basically stands for Elastic File System. And this is basically just a shared drive between multiple EC2 instances. Actually, I'm going to go back and say what each of these stands for. EC2 stands for Elastic Cloud Compute, and ECS stands for Elastic Container Services. So again, yeah, there's acronyms for everything. You just got to get used to it pretty much. So EFS stands for Elastic File System. And this is, again, like a shared drive that you can mount to multiple of your Elastic Cloud Compute instances. So basically, you can just imagine this like Google Docs, but for, oh, sorry, that's what S3 is. But again, like sort of a similar thing. It's like a shared drive, but for AWS. S3 is a little bit different because it's not an actual file system. It's a flat system. So basically what this means is that you can make folders, but everything is really just like in the same drive. Like you can think of it like you can use folders to address it, but everything's really in the same drive of the actual computer that it's being stored on. And you can think of it like Google Docs, but for AWS. It's basically object storage, and S3 stands for simple storage solution. No, service. Simple storage service, or maybe the solution, one of those two. And the way that both of these work basically is that if you need to access, some file, whatever that file may be, you can imagine like it's an image file and you have a server that will serve images, something like, Google Images. It can just go through and grab all of these and then serve them to you. So that takes care of object storage. And then EBS is more of like a local thing. So if you just have like a small amount of storage that you need to attach to one of your EC2 instances, then EBS, which is elastic block storage, is the way to go. There are ways to share it among multiple EC2 instances, but don't worry about that. As far as pricing goes, S3, yeah, what's up?
Start up. Cut down your, does the stuff you have stay there?
No, it goes away. So yeah, EBS, basically you attach it onto a EC2 instance. You can start it when you run it, but it will lose the information if you stop the so there's a difference between pausing and stopping an instance. If you pause the instance, it won't accrue as much cost of actively running it, but the information will still be there. But if you completely stop it and shut down the instance, it will lose the information in that block. So if you're trying to actually store things long term, the best option is going to be S3, especially if you need it to be able to access other services. So for example, what I mean by that is if you're storing like records that a regular person would need to be able to go look at, S3 is by far the best way to do that, because you can go onto like the AWS console and look through your S3 records, and you can click on stuff and open it like a regular file. Versus EFS is really just meant for EC2 connectivity, which makes it a little more specialized and compared to something like S3. And then EBS is again like just for like if you need to store temporary values, that's where you would use that. Database. So database has a ton of offerings. I should also mention right now that you can use an EC2, which is a compute instance, as a regular computer, right? As I mentioned earlier. So you can run your database server on an EC2 instance. The reason that there's so much value in using the AWS offerings is because they're managed services. Okay, so when I was talking earlier about managed, AWS managed and user managed services, for example, you can run whatever you want on an EC2. You can run a web server, you can run a database server, you can run machine learning project. Like it's just a computer. You can use it however you want. But AWS will manage the firmware and the version for the most part on some of these services. So the level that AWS manages versus what you manage does depend on the service. So first off is Aurora, which is completely managed by AWS. All you have to do is give it an IP, define some tables, and you're good to go. So it's a relational database, which means you use SQL, obviously. And then they also have a NoSQL database, which is called DynamoDB. So if you've ever used something like Mongo, which is like a JSON document-based database, it's pretty similar to that. And then there is also RDS, which stands for Relational Database Service. And in this one, AWS will have an image of Postgres, MySQL, Oracle, I think like MariaDB and maybe one more. And you're able to run SQLite, that's the last one. And you're able to run each of these, but it's not going to manage updating the database. So if there's ever like a patch of like a serious security vulnerability, it is going to be on you to fix that. So what it comes down to is how much of a trade-off you're willing to make versus how much is managed by you, whether that's, the company, the IT staff, versus how much is managed by Amazon. Oh, there we go. Okay, and then security. So security could have its own whole section. Basically, there's a lot of security built out into the cloud, and that's because people were just so slow to adopt cloud technologies because of security concerns, especially people who didn't really understand technology that well. So I'm talking like, the CEOs of companies, like non-tech companies, took a super long time to be comfortable with using and hosting sensitive information on the cloud, just because they're like, oh, it's not my data center. What if something happens to it? Which is a valid concern, but there's so many different layers of security built into the cloud that it's essentially like not an issue that you're going to have to really worry about. The biggest security vulnerability in the cloud is going to be your own app. And again, I could do a whole presentation on the stuff that I'm about to talk about, but these are just a couple small things. So the first thing is a service, not necessarily even a service, but just a concept in AWS called the Virtual Private Cloud, which is a VPC. Basically, you can think of this as like a local area network, but for the cloud. So if you have an internal API, for example, if it's running on like, your local host 192.168.whatever, you don't want anyone from the open internet to be able to access that, right? So this is how you achieve the equivalent of that from within the cloud. So you can set up systems in your VPC to either be public or private. And basically the way this works is that you have an internet gateway. And so if you want your system to be able to access the internet, you give it a connection to the internet gateway, and then boom, your stuff is on the internet. If you don't give it the connection to an internet gateway, it's just on the internal system, which means it can be reached by services within your VPC, but from the outside, it's not possible. And there are a lot of options, for example, like, oh, what if I need to update my firmware, update my software, something like that. For example, like if you need to download a new version of a library, there are ways around that where you can do that. I'm just not going to get into it because, I only have so much time. So there's a really big emphasis on identity within AWS. And so a big thing that you'll hear about a lot is what's called an IAM policy, which stands for Identity Access Management. And basically every single, user has an IAM policy. Machines can also have what's called an IAM role, which is basically it's assuming a set of policies when it tries to access another service. And each EC2 instance, each database, each S3 bucket, any of those things will have their own IAM security policies associated with it. And it basically says only people with these identities are able to access this data. And there's also certificate managers, there's firewall managers, and there's also like a couple AI tools to, block out like suspicious IPs. I think it's called like Amazon Macie or something like that. Like if there's suspicious login activity, it'll alert you and stuff like that. So again, there's like a ridiculous amount of security tools. If you go on like the AWS offerings page, it's like the longest by far. There's just like a stupid amount of security stuff. Again, because people were so scared to adopt it at first. So this is how you actually start an EC2 instance. Once you sign into your AWS account and you go ahead and just click that you want to launch, you go to the EC2 page and you click start instance. It'll bring you to this page. And this is where you're going to select an AMI. Again, like I said, there's just a ridiculous amount of acronyms. AMI stands for Amazon Machine Image. And basically what that means is like an image of the operating system that you want to put on this EC2. And you can make a custom one, but again, like these are just the preset ones. So they have Windows, Linux, Ubuntu, and I mean, there's a bunch of other ones. And basically this is just saying like, load this operating system onto this EC2 instance, and that's how it's going to boot. So this is the first section. Next, you're going to choose an instance type. And again, you can get some of these for free. So if you ever want to experiment with this, you can. Just be careful about opening it to like the open internet if you have bad security on it, because like people will use it to mine cryptocurrency. But yeah, there are like free versions, and they just have like a very small amount of resources, and like they're mainly for learning and getting people into the ecosystem. So again, you can see this one, it's called T2 Micro, and you can get it for free. It only has 1 GB of memory. It's got 1 virtual CPU and it's got like slow network performance. So this is the type of thing that would be great for like a personal project and figuring out how to use it. And I mean, they offer all the way to like massive amounts of memory. Like there's the extra large one with 160 GB of memories and 40 virtual CPUs at its command. Yeah, what's up? So with EC2, again, like I said, the computer's always running, right? It's like you're renting a computer. So you're charged for as long as you have this EC2 active.
So,
I'm pretty sure it's a monthly billing cycle. I'm not sure, honestly. I don't think it's a whole lot. I think it's like maybe like a couple months of using it. Yeah. And then so if you look across the top, I included like all the sections. This is the one where you configure it. So you can auto scale, which basically means if you start to get a lot of traffic, it uses metrics such as like CPU utilization, memory utilization. If those go above a certain threshold, you can use something called auto scaling. So let's say like your average CPU utilization is 80% for an hour, then it can automatically launch another version of that and then split the load between those two. So then it's, you can imagine like it's like, 40 or 50% utilization split between those two instead of all of the load on one. And obviously there is a cost associated with this if you're running extra instances. But it can help with making your app. I mean, if you've got more load on your computer, then you probably have more customers trying to access it, right? So you don't want to just say no and not have those customers be able to access your product, your service, whatever you're hosting on AWS. So obviously there's more costs associated with it, but that's just how it is. Network is basically the VPC that you're associating it with. And AWS will give you like a public IP address that you're able to use. And you do have to, if you want to, like they'll give you like preset ones. It's like almost like Google Phone, they'll give you like a phone number for free. If you want more though, you have to pay for more IP addresses. And then the IAM role is obviously the security that's associated with this EC2 instance. And you can configure, for example, like, if you only wanted to be able to access it from your home IP, you could put a security feature on it where like you can only access it from this IP and it'll lock out anyone else. And then, okay, we'll talk about these last other 4. Adding storage, that's just you can put on EBS or connect it to EFS. Tag instances, I'm going to talk about this a little bit more later on, but tags are basically, they do nothing for the actual computer. It's just completely for your purposes. So for example, if it's associated with a certain project, associated with a certain billing department, stuff like that, when you get to like large enterprise size companies, they need to tag all their information so they can look through, everything associated with this part of our business. Let's look through the total cost for that. Security groups, that's for the incoming IP and stuff like that. And then review is obviously just, yes, I want to start this. So a couple of best practices for when you're doing cloud computing in general. Some of these are AWS specific. Tag everything. So this is something, not tagging things is like manageable when, it's your personal AWS account and you have like 3 instances running for your, personal projects. But when it gets to the size of a company, there are literally thousands and thousands of instances running. And like some of these companies will rack up like just from one part of their business, like a $16,000 AWS bill per month. So like, this is like big amounts of money that we're talking about. So being able to organize everything, in AWS has a dashboard where you can, view the cost of everything over time and see if there's any discrepancies in how much you're paying. And you can, filter that by tag. So when you actually get into the industry, if you're working in AWS, which, based on our statistics, there's a very good chance you will be, tagging everything is super important. Something called the principle of least privilege has to do with IAM roles. So that, again, that's identity access management. And this is honestly just a good idea in general. Give every resource access to only what it needs and nothing more. So for example, if you give, let me think of an example here. If you give, let's say you have a front end server, right? And you give that access to your sensitive database information that has all your customer social security numbers. Like what's the odds that someone's able to use like a cross-site scripting attack to empty your database and get all the results of it? Versus if it never had that access in the first place, it would just deny it, right? So this is why the principle of least privilege is really important. AWS has a lot of awesome, and all cloud services have really good automatic backups that'll take images, exact images of your machine, and you can just reload it and you'll be right back. And then obviously there's a lot of critical apps. So for example, like banking software, what else is something that's critical? Health software. So like, you know, a hospital system is probably something that's good to replicate across availability zones or regions. So an availability zone, well, let's start with a region. So there's a couple of regions. For example, there's US East 1 and 2. There's US West 1 and 2. There's, I think, 2 South America regions. There's a couple of Europe regions. And there's other ones like Australia and a couple in Asia as well. But each region is referring to like an actual geographical region. So imagine that there's a really big hurricane that wipes out the Northeast internet infrastructure. Everything in that region you'll not be able to connect to. So that's why you replicate across multiple regions. But an availability zone refers to a single data center or maybe a couple data centers within one region. And there's a couple availability zones within each region. So let's say something that happens on a small scale, like a data center loses power, catches on fire. For whatever reason, maybe a group of attackers is holding the center hostage for ransom, like, whatever happens. That's an example of where availability zones, having something in multiple availability zones can also help. So it really depends on how critical your app is. Again, if you're something like a restaurant, maybe just being in a couple availability zones is fine. But obviously, whatever you use, you have to pay for, right? So availability zone replication you pay for. And if you're in multiple regions as well, you have to pay for that as well. So it really comes down to, determining how often your app needs to be up and how often, everything needs to be perfect and balancing that with cost. And so the last thing that we're going to talk about is infrastructure as code. There's a lot of tools out there. I'm familiar with Terraform. And basically the way it works is that I showed you guys this, right? So having to go through here, I want to select this machine image. I want to select these resources. I want to configure it with these groups and add this storage and give it these tags. That can be really time consuming to do one at a time. And it's also extremely prone to human error. So this is where infrastructure as code comes in. Even using something like bash scripts with the CLI, it's just, imagine you fat finger the wrong script and now you've configured all these resources that are a mistake. So the solution here is to use a markup language to tell a computer exactly what resources you want. And this allows you to create templates for multiple ecosystems. So imagine that you want to have your pre-prod environment look exactly the same as your prod environment. Then you can just run the same infrastructure as code script to configure those resources, and you can, test your pre-prod environment exactly the same as how it's going to appear in prod. And so like a lot of the times, like large enterprises will have templates just for like, a simple EC2 project that serves, for example, using Spring Boot with Java, something like that, something very simple. And it'll have a pretty good estimate of how much compute resources you'll need, and all that stuff will be there for you. So all you have to do is, download it and run that infrastructure as code. Yes.
Since the Terraform is like a code file, you can commit it to like your Git repository.
Yep.
And that way, whenever you're making changes, it can go to code review and get a second pair of eyes on it.
Yep. It also means that if you make a mistake, you can just roll it back. And so the way that Terraform works really quick, you basically tell the your markup language basically says, this is what I want my ecosystem to look like. So you're not saying change this. You're saying this is what I want to have, and it'll make the necessary changes in your AWS to make that happen. And Terraform also works with Google Cloud and with Microsoft Azure. So you're basically saying, I want these resources, And if there's a discrepancy between what resources you have and what resources you want, it'll either delete what's needed to be deleted or spin up what needs to be spun up. And so the great thing about that is that if you make a mistake, you can just roll back to a previous version, like Jonas was saying, and you can just run that with your version control and bring back exactly what you need. So we covered a lot of stuff here. I would say like the easiest ways to dip your toe into cloud computing is to use something like AWS Lambda, and I'm sure that other offerings have serverless services as well, to just create a simple API for your next hackathon. And then you can say you use cloud computing, which is, a lot more than most people are doing for their hackathons. Again, there's also free student credits for a lot of these services. The ones that I showed, like they give you free stuff even if you're not a student, but if you sign up with your UFL, they'll give you even more free stuff, which is awesome. And there's always a lot of online resources to learn more. I didn't spend a whole lot of time going over how to create an EC2 instance because there's so many like 15-minute YouTube videos that'll show you everything you need to do that are extremely simple to follow, where they spin it up right in front of you. And so I figured it was a better use of time to explain the ecosystem as a whole. And it's a great idea to just learn more with some online resources. Get yourself ready for the Certified Cloud Practitioner exam. It's really not too hard. It's like 40 questions. You just like take it at home like an honor lock exam. And it's a really great resume piece. I mean, like it's an AWS certification. And if you want to work at JP Morgan Chase, not sponsored, they'll pay for you to take it. So I believe that's all I've got. So we're just going to talk about a couple more things. Do you want me to talk about them with the elections? Okay. So a couple updates. Next week on December 5th, we have SSD elections. If anyone wants to sign up right now, you can do that. Otherwise, you can send an email to ufssd.org@gmail.com. So registration is going to be open until election starts. If you decide like the day of that you want to run, then we can definitely make that happen. It's a great opportunity though. You're going to give basically just a 1 to 2 minute speech about your experience with SSD and why you think you would be a good fit for the role. Again, nothing super serious or anything like that. You don't need to dress up or anything like that. Just come talk about what, why you love SSD, how you want to make it better. It's a fantastic resume piece. I've been the outreach officer 2 semesters and the VP for a semester now as well. And so, there's so much that you'll learn from being on the board. It also gives you the opportunities to give talks like this one. And if you are interested in being the program officer, basically all you have to do is help book rooms for the events. So basically like how we got CSEA 101 for the semester. And then also help plan meeting and event content. And you don't need to be like a superstar who knows everything about every field of programming in order to be on the board. You just have to care about SSD and want to see it continue. So if you're interested, I would message Param or just reach out to him in person, and he can tell you more about what it's like to be a program officer, or just talk to any of us about being on the board in general. Also next week, we're going to have lightning talks. Basically a lightning talk is just a very quick chat about something you care about. If you want to sign up for it now, you can go ahead. 5 minutes each, and it can be about any topic. It doesn't even really have to be programming related. We've had someone play the tuba before, so it can really be about anything. We've had Beat Saber, we've had why JavaScript / MATLAB is dumb and stupid. Great presentations. And we've had people present personal projects and small random things that people care about, code golf, stuff like that. It can really be about anything. And it's first come, first serve. So if this is something you'd be interested in, I'd recommend getting on that. If you change your mind later, you can always send a message in the Discord and we'll get the link to you. An interest survey for topics for next semester, I would assume. Okay. Yeah. So this is for topics for next semester. If there's anything that you wish we talked about and would like to learn about, then if someone knows it, we'll do it. And if someone doesn't know it, then we'll learn it and do it. So again, like the reason that we do this club is so that you guys can come here and, have stuff that you actually are interested in, passionate about. So please do fill this out if there was something that you wish you heard this semester. We're not completely opposed to redoing topics. especially like stuff that, you know, was like a year or two ago. So what do you want to see in the spring? Again, thanks for coming. This is all three of these QR codes again, in case you missed any of them. And that is all. Oh, I think I might have a question. Oh, just, yeah, run for elections, Eric said.